So if we set it up, negative log of this number right here is 2.7. Okay? That's the pH of a 0.002 molar hydrochloric acid solution. That's about a little bit weaker than what you would find in your stomach. This is HCl is the acid that's found in our stomach that helps with digestion and breaking away connective tissue, and protein degradation, and that kind of stuff. All right, what happens with this? Now we said that OH then would actually be 0.010 instead of 0.005 because there's two of them here that are going to fall apart. So that means to get my hydrogen from the hydroxide, I take 1 times 10 to the minus 14 divided by this number here. And I'm going to get 1 times 10 to the minus 12. Well, I told you if it's 1, that's easy, right? Because the exponent is going to be the pH. But let's do the math instead. pH is equal to the negative log of 1 times 10 to the minus 12. Answer is 12. So the pH of this is 12. Pretty basic. 0.25 molar nitric acid. That means our concentration of hydrogen is going to be 0.25. Negative log of 0.25 is going to be 0.60. That's a really low pH, right? But it's still greater than 0, so it's still on the scale. It's just really small. So it's pretty strong. Okay, questions about that? Can't figure out what? Well, that's, yeah, you got to figure that out. I can help you after class if you want. Look at it. Anybody who needs help with the calculator, either stay and ask me or ask somebody else or something. Because, like I said, you don't want that to be your problem. Make sure you understand this, and then make sure you get the calculator part working. You don't want to miss those points. Okay, so then going back to that first table we looked at, now we can put pH values on this scale and say that's 0, that's 1, and then correspond the pH with the exponents that you see there. Same thing is true down here. When one goes up, the other one has to go down. Okay? All right, now the other way we talked about was if I gave you the pH, what was the concentration? Realize it's all the same stuff now. It's just a different way of phrasing the question. What is the concentration of hydrogen ions if you know the pH is 3.7? Well, remember this, right? To undo the log, to go backwards, you're going to use this. If you were going from pH to hydrogen, you would say pH is equal to the negative log of the hydrogen ion concentration. Here we're saying the hydrogen ion concentration is going to be equal to 10 raised to the power of whatever the negative value is of the pH. Okay? In other words, it's an inverse of the log. It should be on your button on your calculator to show you that. Okay? It's the inverse of the log, 10 to whatever power. So in this case, it's 3.7 is my pH. So I'm going to take 10 and raise it to the power of negative 3.7. When I do that, I'm going to get down here, I'll come to that in a minute. When I do that, my hydrogen ion concentration is going to be 2 times 10 to the minus 4 molar. In other words, 0.0002. Now, what does this stuff mean right here? What this tells me is, what this is saying, is that if I look at, so I know, to check my math, know that I'm right, or I'm close, a pH of 3.7 is between 3 and 4, right? If it's between 3 and 4, that means that my answer should be between 1 times 10 to the minus 3 and 1 times 10 to the minus 4. So I can look and make sure that's the case. That's what this is saying. Here's 1 times 10 to the minus 4. Here's 1 times 10 to the minus 3. It's got to be between those. Is it? And the answer is yes. Okay? That's just a way to double check what you're doing. That's the theory. Okay? All right, so take your pH. Take it 10 raised to the minus pH, whatever that is, so 10 to the minus 3.7. You'll get 0.0002 molar as your answer. That's your concentration value for hydrogen. So let's look. pH is 2.7. pH 12, pH 0.60. Simple. It's a matter of using your calculator, right? Setting the problems up easy. It's a matter of typing it in correctly. So to get the hydrogen ion concentration, take 10 to the minus 2.7. When you do, you'll get that. On this one, take 10 to the minus 12. You get this. That's an easy one because it was an easy number here. No decimals. On this one, 0.60 takes 10 to the minus 0.6 or 0.60, whatever. You get 0.25 molar. Okay? Be able to do these types of problems. Be able to hit your calculator buttons right. Guess what? The pH of something, I can't remember if I'm going to talk about before I give this away. Let me see something. All right, one thing that I don't have up here is that you can calculate. Let me go back one. Let me show you this, so pay attention. See this right here? pH is equal to the negative log of the hydrogen ion concentration. If I wanted to calculate pOH, guess how I do that? Negative log of what, do you think? I take the negative log of the hydroxide ion concentration if I wanted to do pOH, right? That's pretty straightforward. I can substitute OH in for H, but I have to do it on both sides. Okay? So if I wanted to take what's called the potential hydroxide, pOH, that means I would go, pOH is equal to negative log of the hydroxide ion concentration. Okay? Same thing on this slide down here. If I wanted to do this, if I wanted to find the concentration of hydroxide, I could take 10 raised to the power of the minus pOH. I could do that as well. So realize that these are interchangeable. You just can't mix OH and H together. Okay, you just got to keep them separate. Now, let me ask you this. See if you can figure this out based on this scale. If I calculate the pH of something, and I calculate its reciprocal pOH, and I add those two together, what should the total be? 14. Okay? The pOH of something and the pH of something should add up to be 14. So, another shortcut that may not be on the slide that you might want to write down, just in case it ever comes up, is the pH of something plus the pOH of something is always equal to what number? 14. So that means if you've calculated the pH and the question that I have is what is the pOH of something, guess what you do? You take 14 minus your pH and you've got your pOH. Okay? That's easy math there. So just remember that. Don't forget it in case it needs to be used a little bit later.